Hello everyone, welcome to 369 Chemistry, and in this video we are going to do your Perkins reaction and what is the mechanism of it. Okay, and it is an organic name reaction. Okay, so this is an name reaction, important for second year BSc students, very important. And even if you are going for IIT JAM, NEET and everything, so you might know this. Okay, so this is your name reaction. Okay, the condensation of an aromatic aldehyde. Here in this one there is an aromatic aldehyde. Okay, aldehyde, okay, which is condensed. Okay, so aromatic aldehyde, condensation of aromatic aldehyde with an acetic anhydride. Okay, there is an acetic anhydride which is used in the presence of your sodium or potassium salt of the corresponding acid anhydride. Okay, then what we are going to get, your alpha beta unsaturated acid. So your product will be alpha beta unsaturated acid. Okay, why I have just written like this, I can write it in I can give you in writing, but just to make you understand that there is an aromatic aldehyde which you have to take. Okay, so there should be something that is called aromatic aldehyde. Aromatic means which has a benzene ring attached to it. Okay, so aromatic aldehyde should be there, and it should be taking place in the presence of acetic anhydride. So this is your reagent, okay, acetic anhydride, and salt of sodium and potassium salt of this corresponding same acetic anhydride. You have to take this, then you are going to get your product, that is your alpha beta unsaturated acid. Okay, so this is your product. Okay, so we will take an example of it. Okay, see this is an aldehyde, that is your benzaldehyde. You have taken this is an acetic anhydride. Okay, this is the least acetic anhydride. Okay, so this one you are treating this with number 1, that is your H3CCOONA. Okay, so you are using what? You are using sodium salt of acetic anhydride. Okay, because if you break this anhydride, you are going to attach sodium out here, and you're going to get 2 molecule of sodium salt of acetic acid. Okay, so this is, and the second process is your hydrolysis. Then you are going to get a molecule that is called your alpha beta unsaturated acid. See, so this is your acid, that is your, see, this is alpha carbon, which is just adjacent to the carbon which contains the functional group. This is the functional group carbon, and this is the alpha carbon, and this is the beta carbon. So this is called your alpha beta unsaturated acid. Okay, so we will go through the mechanism of it in proper detail, so you can write. Okay, so see here, I have written the definition of it: the condensation of an aromatic aldehyde, okay, with an acetic anhydride. Condensation word means that two molecules, they are attaching itself and getting reduced to some other form in a condensed form. Okay, so there is always a removal of water molecule, formation of double bonds or triple bonds are always seen in case of your condensation reaction. Okay, even if you have an aromatic aldehyde here, also suppose many times you will not get just simple benzaldehyde, right? It can be some other aromatic aldehyde also which has some other like suppose chlorine is there, or on some other ring is also there. Okay, so in that case of your complex things, those in that times we say that ring closing reaction takes place actually in case of your condensation reaction. So this is very important. Now we will go to the mechanism of this reaction. Okay, it is the abstraction of an alpha hydrogen. That means one alpha hydrogen is taken out from the acetic anhydride, which is present in your reaction medium, which we are taking as reagent, with the help of the sodium salt of acetic acid, which you have in that one. It is going to take up, this one is going to take up one hydrogen from this and give you a carbon ion intermediate. Okay, so see here, draw this one like this, which I am doing, so it will be easier for you. Just follow the step the way I am writing. I know it is difficult, but not that difficult that you cannot write an exam. It's very easy. Once you understand the mechanism, you are thorough with your organic chemistry. So see here, this is CH3 COO minus. Okay, this is Na plus you have. Okay, this is the reagent we are using, and this is the second reagent, or you can say the sodium salt of the same acetic anhydride. So this is the base. It is going to take up your hydrogen and it will give you minus CH3 COOH is gone, and now you are going to get this this kind of this kind of an carbon ion. Okay, CH2 minus. Okay, now see. Okay, this is the one. Now this CH2 minus, this is a resonance stabilized carbon ion. Okay, so if this one comes here, this can go. Okay, oxygen will go, so this here, it is going to form your resonance stabilized carbon ion. So O minus. Okay, O, C double bond O, CH3, and here it becomes double bond CH2. So there is a formation of resonance stabilized form. Now we will go for the second step. Second step is the nucleophilic addition carbon ion. Okay, nucleophilic addition of the carbon ion to the tetrahedral. Okay, to the okay, so this step here is the nucleophilic addition of the carbon ion to the aldehyde to form what? To form tetrahedral alkoxide ion. Okay, so in this step, how it is forming, see now the second step, there's we had what? We had our aldehyde, benzaldehyde. Okay, and now we have this as acid anhydride. So write in this form. Okay, just rotate the molecule which we have done. Okay, so that it becomes easier for the mechanism to understand. Okay, now see, this one is going to come attack here, and then there is a formation of tetrahedral alkoxide is formed. O minus. Okay, here comes H, and then there is a CH2 C, then you have C double bond O, O, C double bond O, then you have H3C here. Okay, so this kind of molecule is formed. Now what will it happen? Now there is an internal transfer of acetyl group from the carbonyl oxygen atom to the alkoxide oxygen atom, and this is the formation of cyclic intermediate now will take place. So condensation means formation of cyclic intermediate, or you can say condensing the molecule. A molecule is becoming now condensed. So step 3. So now in this step 3, there is internal transfer of your of the acetylic group. That means internal transfer of this acetylic group will take place. Okay, among the molecule group from the carboxyl oxygen and to the alkoxide oxygen. Okay, so from the carboxyl oxygen, okay, this is the carboxyl oxygen, to the alkoxide oxygen. Okay, so this thing I will explain just through the diagram. Okay, so now this molecule you have, so you draw this one like this. H, you put the H up, O minus out here. Okay, and draw the same way what the thing is now. The way the last molecule, whatever the last molecule is, draw the same way. Now this oxygen, which is in the carbonyl oxygen, now what it will do, since it has more electron, and this carbon is an electron deficient, so this will try to give, there is an internal shift. Okay, so this way there will be the formation of ring. So what will be the next structure right now? So the next structure will be So just carefully follow the previous structure to make the new structure. Okay, so now see here, and then this becomes your CH2. Okay, this is the CH2. Here you have another carbon, you have oxygen, you have oxygen out here, you have carbon out here. Okay, and you have another oxygen out here. Now this oxygen is attached to this, so this oxygen now is coming and attaching itself. Now this O minus, because here the arrow is gone, and now here you write this has to be CH3. Okay, now see, now what happens, now what will happen, now this molecule, what will it do, this oxygen when it will come here, it will try to break the ring. Okay, and acetic acid group, one acetic acid group will be gone now. So now see here, in this step, it's very important, just see very carefully. Okay, now see, this is CH. Drawing, we will draw the second step by following the first step. So here it is this. Now see, oxygen, it is out here. If you don't follow this step, then you will face problem just doing the numericals of this, or just doing you just have to follow the way I'm saying. So now see, follow out here. Here it is the carbon, this oxygen is coming here, so it is forming double bond oxygen. Okay, there is a CH3, there's a CH3. Okay, this has brought there is a breakage of bond, so out here it will be CH2 again. Okay, then there is C double bond O minus. So here in this step, up to this step, this is the formation. Now what will happen, this group will go away. Okay, but as acetic acid, is it not CH, it will be like, if it has one hydrogen, so it becomes your CH3, and then so what will it do in the next step, that will be your step 4. So this portion will go away. Okay, let's see how. Step 4 is your acetylation of the resulting aldehyde. Okay, acetylation of the resulting aldehyde, or you can say carboxylate ion. Is it not, it is an ion now, carboxylate ion. Okay, by acetic anhydride and hydride. There is a question which is used. See, I will explain you the mechanism, then I will ask you the question, and we will solve that question in the next video. Okay, so first let me finish this. Now in this step, what is happening, this step here, you write this molecule, because this is the molecule, the starting molecule which will come. Okay, here it will be CH. Okay, CH2. Okay, C double bond O minus is there. Here also you have OCO CH3. If you shorten this one, it becomes OCO CH3. Then you have acetic anhydride. There is acetylation, we say, that means addition of an I think acetic group. So acetylation, that is CH3 C double bond O C double bond O CH3. So this is the reagent is present in the reaction medium. Now this carboxylate ion, since it is O minus, it will always look for electron deficient carbon. So electron deficiency is there in this anhydride. Okay, so it will come out here, and there is a formation of another molecule like this. Okay, just following the previous molecule, draw in a same way, CHO CO CH3. Here it is CH2 C double bond O. Now O, here it is added again, C double bond O. Then there is addition of again O C O minus. Okay, and here it is, there is CH3, right, because this will be the CH3, so I'm putting out here, there is O minus out here. Now O C double bond O CH3. See, okay, so this kind of molecule is now forming. Okay, now what is the next step? There will be removal of acetic acid. How? See here again, see, it is going to come out here, this one is going to go out, so minus CH3 COO minus is there. Now So this is going to form another molecule like this. Okay, CH O CO CH3 CH2 C double bond O O C double bond O CH3. So there is a acetic, total acetic anhydride which is added to the carboxylate ion. Okay, so now we will go for hydrolysis. The fourth step will be the step of your hydrolysis. There is often, because see, I have done, there can be fifth step where there is an elimination of your acetic anhydride, but I have done in the same molecule only, in the same step only. So now we will go for the hydrolysis, which is the most important step of this reaction mechanism. So see, this is the molecule which was finally formed, right? Okay. Okay, O C O C H3. Here there is H. Suppose I'm writing this one like this. Okay, then you have C double bond O O C double bond O CH3. This is the same molecule which I've written. Okay, now see here, what is happening now? Is it not? It is there is one molecule which we can remove it. Okay, so if this goes out, is it not CO CH3 COOH? So again there is a loss of this carboxylic acid molecule. Okay, so it is going to form like this. This was the step which was in number 5. Then we will go for hydrolysis. Now we will go for hydrolysis. See this one you write as it is, OCH3. Okay, so if it is visible to you now, so now this is the final molecule which is undergoing hydrolysis, that is CH double bond CH C double bond O O C double bond O CH3. Okay, so now this, there is hydrolysis means H plus. Okay, so see here, oxygen being electronegative, what will it do? It will try to take up hydrogen. So if it is taking up hydrogen, what it is forming? It is forming this CO. Here it is getting H, right? There's a formation of plus sign because this is adding here. So if it forms like this, we can write like this, or you can write directly OH also. It depends on you. I think we should write this way, it looks good here. So we are understanding now. Now what happened, this becomes electron deficient, water is there in the reaction medium. So now this water, it will go and attack this carbon, this anhydride. Okay, so it attacks the anhydride, CH double bond CH. Now see here, it is like this. Now this oxygen becomes this becomes OH C O C double bond O CH3. Okay, now there is again minus H plus is there. So what is the thing? There is a formation of this molecule, COH and OH. Okay, and then O C double bond O CH3. Okay, so now see, if this H goes away, this acetic anhydride molecule goes away. Okay, minus CH3 COOH, what are you going to get the product? Because you have to always take out the smallest possible molecule. Okay, so if you are taking out this, now what we are having this C double bond O OH only. Okay, this acetic acid has gone away. So this is not, is it not, this is your alpha beta unsaturated acid. we have done the mechanism of Perkins reaction. We will do some more examples and questions based on Perkins reaction, which actually comes in your competitive examination, your in graduations also. So we will do that in the next class. And I will also, I told you I will ask a question that why we are using the acetic anhydride we are using, but why sodium salt of that same acetic anhydride is used? Why not other anhydride is used? Why not other salt of acetic anhydride is used? Okay, so this is a question. Do homework and let me know in the comment what is your answer, and if you don't know, we will do and discuss in the next video. Thank you so much.